All right, let's take a look at first the response question, take-home test. We've got these two functions, and both are very similar. F just has a multiplier out in front of it. It's between 0 and 1. So what that means is, since that's less than 1, it's always positive. The shape of the graph is going to be the same. It's just going to be a lot. It's going to be a lot smaller. So let's see. Let's look at the draw a little bit better. We're going to have the same general curve. It's also going to intersect the same spot, both 0 at positive 6 and negative 6. So anyway, the top curve is clearly this g of x. Right? So part 1, or part 8, is asking me to find the area of R, which is defined as the region in the first quadrant bounded by the y-axis in the graph of f and the graph of g. So looks like we just have to go from 0 to 6, and we're going to have to g of x minus f. Perhaps take this a step further on this one. G of x is 36 minus x squared. This is a times 36. One way to look at this is that both and 36 squared. This is 1 times it, right? So it turns out that you could actually write it as 1 minus a. You factor that out, it becomes a constant. 1 is a constant, and a is some constant here, 0 and 1. So we have 36 minus x squared. And then we have what? Minus 36. Plus x squared. Well, actually, think about it for a second. If we factor these out, now let's see. Think about redistributing back into the original equation. Multiply by 1, you get the first equation. Distribute to minus a, you get the second equation here. So really, this is just the interval from 0 to 6 multiplied by this constant. So surely we can use a calculator on this part. So I put both the equations in here, and I just made up a thing value of 0.5 for the second, because that's fairly 0 and 1, halfway, right? So really, what am I looking for is the interval from 0 to 6 of this first function. Let me go ahead and turn this on. And I zoomed in so I can see the graph in the first quadrant. So we can certainly do it from graphic by going to calculate and taking number 7, going from 0 all the way to the crossing point at 6. See that it's equal to 144. So what we have is 1 minus a. This evaluated is 144. So if we write it, say 144 minus a times 144. That should be sufficient. Okay. On part B, they say find the equation of the line that's tangent to f. So tangent to f at the point 6, 0. So at 6, 0, call this 6, 0, f, which is this spot here. We're looking for the tangent, right? So at the point, we have a point 6, 0, so we just y minus 0 equal to the derivative of f x minus 6. So this will find the equation tangent. So don't be too confused about 2/5 36 times a. And we can say that this is a constant. So we pull the constant out. So what's the derivative of this function? So that becomes 0 minus 2x is the derivative. So what value we're trying to find? We're trying to find it at x is 6. So minus 2 times 6 times that a out in front of there. So it's just going to look a little funny, but it's going to be in terms of a. So we found our derivative, and then we can clean up. Insert it right here. Okay. Well, part C says determine the value that divides the region into two parts equal areas. So we're trying to find some value A that will cut it in half. And we've already found what? We've already found the area part. Area. So basically, we're just going to do the same analysis. We're just going to take half of this value. That's what it's asking us to do. So on part C, pretty much we're going to take 1/2 of 144 times this 1 minus a, and set it equal to the integral of our original function. Okay, so I'll let you figure that one out. Going from 0 to 6, of course, and the top curve minus the bottom curve. Looking for the line that divides the region into two parts. So good luck with the rest of that one. Hopefully those helps you.